Okay, so this last method for solving our systems, right, finding where they cross, is called elimination. And it's kind of a cool method. Sometimes you see it called the addition method. Either one, same thing. All right, and it kind of goes through a summary. Oh, they kind of moved on me. That's okay. All right, so when we look at this first problem, they're both in the form x, y, number. We do not like that method because we'd have to solve for a letter, substitute them in. It's just a little bit ugly. So this one would be easier to use our new method. So we're going to take, I'm going to write it just under because it's better. We're going to take and look at this and see if we can add the equations together, add the x's, add the y's, add the numbers. Do we eliminate a letter? Does a letter add to 0? Okay, so that's why it's addition. You're adding them together, but you're eliminating a letter. So you can see where both those elimination method, addition method kind of come from. So this one does work pretty. So we're going to add them. What is negative 2x plus 2x? 0. So those two terms go to 0. And then I can go 1y minus 3y is negative 2y. 10 minus 2 is going to give me 8. Now I've eliminated a letter and I can easily solve for y. Negative 2 goes into 8, get to ignore that 0. And y is going to equal negative 4. Pretty quick. I like it. So then over here, I got to take that top equation and substitute in the minus 4 and solve for x. A little bit uglier equation, but that's okay. Add the 4 over, and I'd get negative, that goes to 0, negative 2x equals 14. Divide by negative 2, and x is negative 7. So there's our point, negative 7, negative 4. Kind of a cool method, but they do have to be set up kind of pretty. So let's look. This one doesn't have it written underneath. I'm going to write it underneath. And you could always move around your equations and use this method, but you want the equations to be lining up x, y number because you can only add like terms, so you have to have it set up that way. Right now, 4x and x do not add to 0. Y and negative 3y, they don't add to 0 either. So this one is not set up to just add, add, add. Dang it. We wish. What number would we like to be right here to make the x's add to 0? Negative 4. What number would we like to be here to make the y's add to 0? A 3. So you could multiply, pick x or y to eliminate, and you could multiply the top equation by something to eliminate. So I'm going to just stick with, maybe I'll do the y just because we did the x in the last one. So I am going to multiply this entire equation by 3. And that will make it be 3y, so the 3's eliminate. But you can't just multiply the y by it. You have to do the whole equation. So the new equation will become 3x plus 3y equals negative 3. I have times every single term by negative 3. So the solution's the same as x plus y equals negative 1. But it's just written a little bit different. Okay, now I'm going to write the other function underneath. And now we have our addition problem, and we will eliminate the y's. Positive 3 minus 3 is 0. They have to be opposite signs, same number. Now, 3 plus 4 is going to give me 7x equals 24 minus 3 is 21. Okay, divide each side by 7, and I got x is 3. Okay, now I have to find y. I can just go back to that first equation and go 3 plus y equals negative 1. Minus that 3 over, right? Minus the 3, and y is negative 4. So our point is x, y. You can write it, sometimes you put in the x and y separately. Either way is fine. It's still the point in which these equations cross. We just don't graph it to look. That's our elimination method. Okay. Now, these ones. No, I was looking for ones that didn't have a solution. And then we have our word problems. Gosh darn, guys. I don't know if I set up one. Okay, we're just going to cross these out and we're going to write our own in this problem 3. I want you to write out 2x minus 4y equals 7. And I want you to write negative x plus 2y equals 10. Okay. So these are going to be our new equations because I haven't shown you any that have no solution or many solutions. I thought I had one on here, but I think in the past, on the note packet, but I think in the past I just added one at the end. Okay, so we're going to do this with elimination. So right now, if I add the x's, they don't add to 0, and the y's don't add to 0. So if I multiply the bottom function, the whole thing by 2, then I could eliminate my x's. So let's do that. The top one stays the same. And the bottom one's going to be times by 2. That's going to make negative 2x plus 4y equals 20. Okay. Now, when I go to do the problem, the x's and the y's eliminate. So I have 0 equals 27. That's strange, right? If I go to solve and my x's and my y's add to 0 in any way, it could be substitution in it, or it could be in elimination. That means you either have no solution or many solutions. Look at what's left. If I have 0 equals 27, that means no solution. That's never going to happen. 0 can't equal 27. What if my answer would have been 27 equals 27? Then it would have been many solutions. Infinitely many. They are actually the exact same. It didn't matter what number you put in, you will get the same number for both equations. Okay, so this one's no solution. Let's make a new one that has the many solutions that we haven't seen. So let's see here. We could have, I wish I had a harder one off the top of my head, but that's okay. We'll do negative x minus y equals 2. Negative x minus y equals 2. And then we're going to do negative 3x minus 3y equals 6. Okay, now we still want to do the addition method, but right now when I add down, the x's would go to -4, y's go to -4, right? So it's not going to add to 0. So I can times the top one by -3. You could also, it's legal if you want to times the top one by negatives, the bottom one by, or top one by 3, bottom one by negative. Like you could multiply both equations. Like if this would have been a 2 here, I could have multiplied this by 3, this by 2 to get 6. So you can always multiply both if you wanted. But I could multiply this one by -3. And that would then give me +3 on that x term. You might notice it also gives you where the y's would cancel too, but that's okay. We'll see that in just a sec. So times everything by -3, and I'll get 3x plus 3y equals -6. And then on the bottom, I still have -3x minus 3y equals 6. Now, when I add them down, I get 0 equals 0, like everything added to 0. This means you have infinitely many solutions. This is the infinite symbol. So we have infinitely many solutions. All right. So you could end up with that as well. Okay, so on it didn't label them 1, 2, 3, 4, 5. It labeled them 1, 1, 1, 1, 1, 1, 1, 5. That's so funny. This is just it comes through from Word document into Notability a little weird. And I should have saved it as a PDF, but I forgot. So the word problems definitely are challenging, okay? So number 1, the difference of two numbers is 3 and their sum is 13. Find the numbers. We should get 2 equations on all of these and then solve them whatever method we want. So I can read this again. The difference of two numbers is one equation and their sum is another. What does the difference mean? Minus subtract. What does the sum mean? The sum means to add. So I have 2 equations with subtracting and adding. And then we have to find the numbers. Because I love x and y, let's call our numbers x and y. So we would say the difference of the two numbers, x minus y equals 3. The sum x plus y equals 13. So these are 2 equations. Which method should we use to solve these? It's set up pretty for elimination that we just covered. Could you easily do substitution? Yes. I could actually just add the y over and substitute that whole thing in for x. Both methods are actually pretty easy to do, so your choice. I say big addition problem. And the y's add to 0. What is 1x plus 1x? 2x. Okay, don't forget to add those. A lot of times people just put x. So, 1 plus 1 is 2. You have 2 of them. And then 13 plus 3 is 15. Oh, this one has a fraction. Oh, 16. I can't add. Just kidding. So 16. So then divide, and x is going to be 8. Now substitute that back in. I kind of like the second equation better for substitution. So x, I did it twice. Did not x. 8 is x plus y equals 13. And then minus the 8 over and get 5. Okay. This is our 2 numbers. So you have to write the numbers are 8 and 5. You can't say x equals y equals. Those are variables we use to solve the equation. We don't care. They have no meaning in our original problem. 8 plus 5 does add to 13. 8 minus 5 makes 3. So it solves that equation. Oh my goodness, now we're going to fly. We're flying to Kampala. Kampala? I don't even know where that is. With a tailwind, a plane averages, so the plane has a tailwind, right? The wind is pushing that airplane. Okay, it's speeding you up, and that's 158 kilometers per hour. On the return trip, the plane averages 112, flying back with that same wind. So this time it's going to slow us down because we're flying into the wind. Find the speed of the wind and the speed in still air. So let's pick a couple notes just for this type of problem for you. Tail wind will add, speeds you up. And I don't know how to say, doesn't have a fancy name. What if you're driving into the wind? Like, I don't know what that's called. Into wind, right? then you have to subtract from your speed, because one will speed me up, one will slow me down. Just a thought process for you. Now let's let X and Y be something. So X is going to equal maybe our speed for our still air, because we have to find the speed of the still air and the speed of the wind. I'm going to let X be the speed of the still air. Then we'll let Y equal the speed of the wind. Okay. All right. So then our equations will be, okay, the speed of the still air plus the speed of the wind has to be going 158. You realize when I say the speed of the still air, like how fast are you just going if there's no wind? I feel like that's a little weird, but the still air one is just how fast are you going with no wind? Then that wind will add to your speed. And that's where this is what this is saying. How fast are you just going? And then this will speed you up, that wind. So if you're going back the other way, it's going to slow you down to 112. And that's the equations that you'd come up with for this one. Okay, this one's set up really well for addition method as well. 2x plus 2x, sorry, 1x plus 1x is 2x. Y's cancel. 158 plus 112. Oops. You probably already got it, but that's all right. I'm going to still, my calculator, this is the fancy one. It kind of was in a weird setting. So I got 270. And then I'm going to divide that by 2, and I get X is 135. So I'm going 135 kilometers per hour in still air. So that's just how fast my plane's going in still air. Now I have to figure out how fast that wind is pushing me. So back into either equation, I'd get 135 plus, I don't know, equals 158. Subtract over the 135. So 158 minus the 135 is 23. So that is your wind speed. And that's still kilometers. So they're both kilometers per hour, your speed. Okay, so there we go. The plane's going 158 and the wind is 23. All right. Each of these problems is completely different, just so that you see me show you different ones. So this one, problem number 1 for the third time, is going to be a company that manufactures small canoes has a fixed cost of $18,000. It costs $20 to produce each canoe. The selling price is $80 a canoe. Okay, write a cost and a revenue function. Find the break even. So we just went from wind to we went from adding and subtracting wind, and now we're like money. What is a cost function? How much this thing costs you to make it? Well, what is our price? What, $20, right, per item? Plus you have a fixed cost, $20 per item plus a fixed cost. Okay. So I was trying to think X and Y. I don't think you write the revenue. One is going to be, so X, let's do X as revenue. I have, yeah, I had to think about it for a second. Sorry. Let's let X equal revenue. And we haven't really looked at that real closely yet. And we'll let Y equal our cost. Okay, so we've looked at the Y a little bit. So Y is going to be our cost. So my brain goes, what is X and one is Y? Not X is the number of items sold. Okay, yeah, no. Yeah, that's how we're gonna do it. X is always the number of items sold. X is the number of items sold. And this would be canoes. They're just items, they're canoes. Gosh darn it. And Y is gonna be the price or cost. So the reason why I'm pausing is because I teach this completely different in a different class. So I was like, ooh, how would I will show you what X is and what Y is. So I just think of this in terms of cost and revenue. So when I go to think of the cost function, I'm going to put this in function notation because that's what makes sense to me. Cost. How much are my fixed costs? Like that's going to be like your overhead costs. That's going to be your house, or not your house, but like your building and your heater, air conditioning, all those different things. All of those into one is $18,000. And then how much does it cost you per item is $20. So you would set this up as $20 times however many items you sold plus the $18,000. That's how much it's going to cost us. $20 a canoe plus I have all these other fees that add up to 18,000. So that's how we always set up our cost. Our cost is always fixed, all by itself, added at the end, and per item cost times by X. Okay, revenue is going to be your price that you sell those canoes, $80, times the number of items that you sell. I make $80 per item. Okay. And when I'm finding the break even point, what I'm finding is where am I going to actually start making money, especially when $18,000 is a ton of money. How many canoes do I have to sell before I actually break even and pay for my bills? Okay, so I'll just do it over here. This one is not set up well for elimination. We haven't done substitution in a little bit, but we can easily substitute, like think of it as we want this to equal this for break even. Okay, so that's where we want these to equal. So when I set this up, I'm going to go 20x plus 18,000 equals 80x. Then I'm going to solve from there. So I'm going to minus the 20x over because otherwise I'm going to like lose my x. So minus the 20x minus the 20x this way. 18,000 is going to equal 60x. 18,000 divided by 60 is 300 x's. X was the number of canoes you have to sell. My goodness, I have to sell 300 canoes before I even make zero money. Holy moly, not a good business. You're got to bring down your cost, right? That 18,000 is just too much money. Now, you can plug that into revenue to find the other value, the cost. So 80 times 300 is 24,000. And so this is your money. I don't have a place to write this well. I would need to sell 300 items and I would have to make $24,000 before I start to make money. I hope you look at this problem and think, oh, like this is actually useful. Like I could actually see myself in my businesses or in work using this idea. Okay, two more problems. So this Kim lab is testing some stuff and they say they have a solution that is 80% and a 30%, and they want to mix 150 liters of solution and get 62%. They're taking a little 30, a little 80, and they're going to blend it up and get a 62% base. Okay, so how are we going to set this one up? Well, let's let X equal how much? 80%. The amount of 80% solution, and Y can be the amount of 30% solution. Okay, so then from here, we can set up our equations. Goodness, so we could think of this as the amount of liters in general. That's going to be hard for you to think of. And then using the percents. So I'm going to do the percents first. I have 80% times X, because that's the variable I chose for 80%. So 80% of however much that I have of that solution, plus 30% of however much I have of that solution, is going to equal the total amount of solution, which is 150, times my goal. And this goal would be 62%. Amount times percent, amount times percent, amount times percent, all the way across. Amount, percent, amount, percent, amount, percent. I know I wrote these backward from the other two, but you get the idea. The other equation would be the amount of X and Y has to equal the 150. The amount that I pour in each is 150 liters. They gave me that. That'll be the harder equation to like think of. Then from here to solve these, probably substitution method would be the best. I would like minus the Y over, and I would have X equals 150 minus Y. And now plug this into the other formula here. So I'd have 0.8 times 150 minus Y plus 0.3Y equals, I can actually figure out that number. 150 times 0.62 is 93. Okay, then from here, I gotta just solve this and distribute. I'm out of room, so I'm just gonna like cross this problem out and keep going below it. So 0.8 times 150, 0.8 times 150 is 120, minus 0.8 times Y plus 0.3Y equals 93. And then negative 0.8 and 0.3 are going to combine to negative 0.5Y. And they have the 120 and you have the 93. Then minus your 120 over. And I get negative 27. Okay, and then divide that negative 27 by negative 0.5. I got 54. So the amount of Y solution is, the 30% solution is 54. Is this ounces, liters? I don't know why my nose is running so much. I'm like allergic to teaching this lesson. Okay. From there, we have to find the amount of the other solution. And we know that the solutions add to 150. So we could think of our X equals 150 minus the Y we came up with. So 150 minus 54 is going to give me 96. So you would write out the solutions as, we have 96 liters of 80% solution. We have 54 liters of 30% solution. Oof, that one's tough. Okay, one more problem that I crossed out. So pause if you need to write this down, because I gotta erase it. You guys can always go back in time. Okay, that's the beauty of a video. So here we are. I have a bag that contains nickels and dimes. There are 3 more dimes than there are nickels. Altogether, the coins total $1.80. How many of each coin do you have? So I'm going to let N be nickels because that's easy. for me, and D be dimes. You can use X and Y because we know we all like X and Y. And let's think of nickels as 5 cents in terms of money and 10 cents for dimes. We have to think that through. Like, that's really, I'm making 5 cents per nickel. Right? Okay, so how do I say that there are 3 more dimes than there are nickels? How would I set up an equation where they're equal? Which one's smaller if there are 3 more dimes than nickels? Nickels is smaller. I have less nickels. There are 3 more dimes than there are nickels. So I think of, if I take my nickels and add 3, it would equal my dime. You could have also thought of dimes minus 3 is going to equal nickels. You have to think of how to make an equation where this piece equals this piece from that information that was given. Okay, so here we are. That's my first equation. Now, let's think in terms of money. This is our number of dimes and nickels, and then money is our second equation. So money is, all right, so I have 5 cents per nickel, plus I have 10 cents per dime, and that has to total $1.80. All right, then I can plug this in for D, and that would now give me 0.05 N plus 0.10, take the D out, substitute in N plus 3 equals 1.80. Okay, so let's distribute and add our like terms on that left side. So I do too know that, duh. So this is 0.05 N plus 0.10 N. You could just do 0.1, and I don't know why I still have the 0 there. And then that would be plus 0.3 equals the $1.80. Add those ends together and I get 15 cents or 0.15 N. Plus 0.3 equals the $1.80. Now subtract that over 1.8 minus 0.3. I get 1.5. So here I am. I want to put this in, equals $1.50 after I minus the 30 cents, and divide, and my nickels is 10. I have 10 nickels. Now, go back to this original. If I have 10 nickels, I'm going to have 13 dimes. Okay, so there's going to be 13 dimes. 10 nickels, you would write the answer out. 10 nickels, 13 dimes. You can't leave it X and Y, N and D. You have to go back and tell me what you found, and you need to check, does that make sense? If I have 10 nickels and 13 dimes, does it add to $1.80? It does. So double check your work. I know the word problems are hard. I tried to give you one of each type I could think of. Okay, please send me the Ask the Instructor. That sends me your problem in my email, and I respond to the email that you registered my math lab with. So that's typically your Sheridan email, so make sure you're checking that. Okay, catch you later.